We will start with Misko. Misko created Angular, I think now 10 years ago. And he worked at various big companies like Adobe, Google, and I think the list is pretty long. And it seems like he's not done yet because he started another framework called Qwik. And I think Qwik has some pretty interesting ideas on how to improve the web. And I think we will get started with that.
So, my favorite thing is when I start a presentation, I always like to tell a dad joke. And I keep my dad jokes in a database. No? How do functions break up? They stop calling each other. No? Man, tough audience. I need to...
kind of typical dad jokes. No one's laughing.
Typical dad jokes, no one's laughing? Okay. When is a joke a dad joke? When the punchline is apparent.
My people.
Thank you.
Great.
Somebody is enjoying it. Somebody's enjoying it. Okay. So today I want to talk to you about Qwik. And Rich, your job is to keep me on time. So like, give me some allocated time, and at some point you can tell me that I went too far, and we can stop. And yeah, so originally I built AngularJS back in the day, I think it was 15 years now. It's a pretty long time ago. And I think Qwik is one of those things where you kind of, after the fact, you'll kind of learn and you're like, oh yeah, I made all these mistakes. I'm going to do it correct the second time, or the third time, or whatever it is. And so there's a couple of interesting ideas in here. And fundamentally, the thing that Qwik tries to solve is speed of loading. And I'm sure you've all had this experience where you navigate to a website. Somebody sends you links to like these latest shoes or something. I don't know. You come to a website and you want to hit the buy button, and you click and nothing happens. And so you're like, is it broken? What's going on? And then you click again and then nothing happens. And eventually, 15 seconds later, you have 3 shoes in your shopping cart. And at some point, you just say, you know what, forget it, I'm going to leave. And the reason why this is happening is because we are sending way too much, both code, but also JavaScript to the browser. And JavaScript is especially problematic. And so the thing that Qwik wants to figure out is, how do you send the least amount of JavaScript possible? Ideally, you should send nothing. And then as you interact with the page, then you should only send the amount of code necessary for that interaction. So if people click on a buy button, then you should only send the code necessary for clicking on the buy button. You shouldn't send the code for other things, right? And you should also learn from how the users use and recognize that, like, oh, the buy button is more important, so I'm going to send that code first. And maybe the logout button is less important. I'm going to send that last, or whatever the combination of things are in there. Okay, so the first thing to kind of understand is this thing called hydration. So let's talk about hydration, and hopefully I'll be able to kind of paint the picture why Qwik is different. So this is how most frameworks work. This is certainly how Angular works as well. And so what happens is you get a page and it's gray, meaning that it's not interactive, right? This is your situation where you navigate to a page, you want to click on something, nothing works. And so you wait, and so the browser finally gets the HTML, and then it downloads the code, and finally, once the JavaScript shows up, it starts from the root and slowly visits all the components and registers the click handlers and kind of makes the page interactive. And it is at this point that you can go and click on the buy button and everything works. And so you start this page like this, and then over time it gets bigger, more complicated, and you realize, okay, I have way too much code. Right? Like, it's not unheard of to send hundreds of kilobytes, up to megabytes of JavaScript on a large application. And so people say, like, that's fine, I can do lazy loading, right? So lazy loading solves everything. So let me show you why the lazy loading doesn't really solve everything. So first you come to a page and you go and you download just some JavaScript, and all of these other parts are lazy loaded. But guess what? You still can't interact with them. You still need to download all of these parts as well. And so if anything, now you have to do more downloads until everything is downloaded. So the thing about lazy loading is that lazy loading only works for components that are not currently on the render tree. If the component is visible and needs to be hydrated, lazy loading isn't going to save you. Right? Lazy loading is good for something that is not currently visible or something that's in a separate route. But if you have it as loaded in front page, And from a view like the buy button, there's no lazy loading or no way you can get around this particular problem. So then people come up with this idea of Astro. They said, you know what? Most of the page is static. So maybe the only thing we need to really hydrate is this portion over here. So instead of hydrating the whole thing, only a subpage gets hydrated. And so you start with something like this. Maybe this contains your buy button, but then over time you kind of realize, gee, but I also want the menu to work, and I want the side menu to work, and the comment section to work. And the next thing you know, you're just hydrating the whole world anyways, right? So that's another approach. Now, let me show you how Qwik is different. So Qwik has this interesting property that, well, let me go back up a second. The reason why hydration is necessary is because the framework needs to figure out where the click listeners are, right? If you just have a page, HTML, there's no way for the browser to know where the click listener is, right? And the only way to do that is to download the code and execute the code. And as you're executing the templating code, you basically discover and learn, or more specifically, the framework discovers and learns where the click listeners are. Right? So until the code for this page downloads, the framework has no way to making it interactive. The framework must get the JavaScript for these particular components and download everything. Now, the way Qwik is different is that Qwik, just like many other frameworks that have server-side rendering, pre-rendered the page on a server. But the unique difference is that most of the other frameworks, when they rendered things on a server, they produced HTML and sent it to the client. The thing that they threw away are locations of all the listeners that it doesn't get sent to the client. And they also throw away the state of the system. In other words, like, what did you have in your shopping cart? Or, you know, the location of the carousel or something. It doesn't matter. Whatever the state of the page is, none of that stuff really gets sent to the client. So when you come to the client, you have to redo everything. What Qwik does different is it saves those two pieces of information. So when the page comes up like this, no JavaScript is present. And if you want to go and interact with a particular thing, let's say I click on this particular button, the system knows that there's a click listener because it's serialized in the HTML. And it's only at that time that you get the code and download just that piece of code, not the rest of the page, just that piece of code. Now, I know what you're thinking. You're thinking, yeah, but doesn't mean that's slow. Like every time I click, I have to go to the network and fetch stuff, etc. We'll talk about that in a second. With all the pre-caching and all the magical stuff we do to make sure that it's not slow. Basically, the way the system is set up is that when you go and click, it's a cache hit for you from the browser's point of view. We'll talk about that in a second. Now, the thing I want to show here is this looks very similar to, you know, island frameworks like Astro, where individual things are. But let me show you something that is very, very unique. Let's say I interact with this component right here. Notice the thing that happened over there. Neither the parent components nor the child components had to be, I don't know what the word you want to use, hydrated or loaded or, you know, none of that stuff has to be present. The unique property that Qwik has is that it can wake up individual components without waking up either the parents or the children. If you look at how most hydration works, most hydration cannot hydrate in the middle of the tree. You have to start at the root, and you have to recursively go through the children. You can decide whether you want to go to the left child or right child, or maybe if you're really smart, you can skip individual components in between, etc. There's lots of tricks you could do. But fundamentally, you have to start at the root, and you have to go towards children, right? Because Qwik serializes all of this information about where the components are, where the listeners, what is the state of the components, and all the information inside of the static form inside of the HTML, you can wake up individual components. And I think even waking up is not the right word here, because let's say this is a buy button for a second. Let's assume that this is a buy button. If I click, notice what happened. When I click here, it also woke up another component. And this is an important thing. Let's say you have a buy button and you have a shopping cart. When I click the buy button, I need to go update the shopping cart. But if all of the items are independently lazy loaded, how is the buy button supposed to communicate to the shopping cart? Right? The way most people solve this problem is that you put the state in the least common ancestor, which between the shopping cart and the buy button is pretty much the root of the application. And then they make sure that they hydrate starting at that location, which means that you pretty much are hydrating the whole page, right? So this is kind of the basic idea that Qwik has, and the Qwik goes for it. Let me let me actually, before I show you how all this magic works, I want to talk to you for a second about this idea that like, oh, so you don't download the code until you go and interact with the button. Well, doesn't it mean that the interaction is going to be slow because now you have to go and fetch the code and interact? And then I'm going to show you what we do to kind of make sure this is not the case. So the first thing to understand is that Qwik can, normally when you have frameworks, the lazy loading component, or rather the minimum lazy thing you can download is a component, right? So you can decide like, okay, I want to lazy load this particular component. Component is your kind of the boundary. Qwik, the minimum thing you can download is not a component, but rather a function. And so you can download things like just the click listener for this particular component. For example, if you have a buy button, the component contains both information about how to render the buy button, but also the information about what should happen when you click on a buy button, right? But if you're actually using the buy button, you don't actually need the information about how to render it, right? Because when you click on a buy button, nothing happens other than like the shopping cart updates. So really what you want is I click on a buy button, so I need the click handler, I need the code behind the buy button, and I need the rendering behind the shopping cart. But the way most systems work is they'll say like, no, the minimum thing you can lazy load is a component, and therefore you need to lazy load both the buy button click listener as well as the rendering component that's associated with the buy button, even though you're not going to re-render the buy button because like nothing has changed on it, right? And you also have to go and download the shopping cart because that's what's going to be updated. But you can't just download the rendering part. You also have to download all the click listeners associated with it because again, it's together into a simple component. But Qwik separates those two things and you can actually just download individual things. And so what you want to get into the situation is you want to make sure that your buy button code is bundled together with your shopping cart rendering code, right? Because that's the ideal situation you want to get to. So how do you get there, right? So one of the things Qwik has is something called Qwik Insight. And let me see if I can zoom this up a little bit. So this is kind of hard to see this matrix, but it's a matrix. And if I hover over a particular pixel here in this matrix, it gives me two things, row and a column. And so each function gets a hash that you see over here. So that basically says that if somebody needs a function, whatever the YH0 function is, then there's an 82% chance that they're also going to need this other function. Right? And this information is something you collect as the application is running. So like you deploy your application for buying, selling shoes or whatever. People come and click on the buy button and different parts of the page kind of update. And so as this is happening, the system is collecting information and says, I see what the average person is doing. And then next time you release a new deployment, this information is actually going to be used. And so you can do AI, whatever fancy term here you want to use. But anyways, the system can automatically kind of notice that these things come together and bundle them. So the system automatically created these bundles. It basically said, I think in order to get the best performance, you should put these functions in bundle A, these functions in bundle B, and so on and so forth. And so this information then gets downloaded and sent to the next time you deploy your application, right? See, I have some other nice pictures somewhere. No, somewhere here. Of course not. Okay, never mind. Okay, so that's the basic idea. Maybe we'll talk about some lower level demos. Okay. So let me show you a basic page. So this is just a basic page. There's nothing in it. And I don't think this is going to be that exciting, but let's make the font bigger. Come on. Okay, the thing I want to show you is the network. And this is in dev mode. So we're running Vite and the only thing I'm interested in is JavaScript, and I'm going to refresh. And Vite sends a bunch of things in. So I'm going to say -Vite. That's for hot module reloading. So I'm saying pretend Vite doesn't exist. This is not because we're in a dev mode and production doesn't exist. And what I want to show you is that you navigate to this page, no JavaScript shows up, right? Because I put a filter for just JavaScript. And of course, nothing shows up because, well, it's a static page, right? There's nothing here. It's nothing of interest in this particular page. And so because of that, it's not really that exciting. Any framework can basically not send any JavaScript if you don't have any behavior on this particular thing. So let's look at a page that has behavior. Actually, let me do this. Okay, so here's a counter. And I want to show you is like, look, again, no JavaScript shows up. And maybe I'll click greet. And notice it's when I click greet, did the code show up? Now let's see what showed up. So in this particular case, I think this one just does a console log. Here we go. So me hitting greet just, sends a console log. But the thing I want to show you is that, again, if I refresh the page, there's no JavaScript. When I hit greet, the greet shows up. Notice, it's just the code associated with console log, right? I didn't send all of the components on the page, and there's probably like around 30 components because it's running the full, what we call the meta framework that's with it. There's also this plus button that has behavior. There is this thing that has behavior because it updates, etc. There's many other components on a page that are interactive, right? But the point I want to make is that, look, you only push that button. So why should I send all this other code to the client? Now, at this point, you kind of see how the quick insight kind of makes the bundling and everything else kind of work, but you still might be thinking like, what, doesn't it mean that you're going to be slow on a first interaction? Well, this is where a service worker comes in. So there's a service worker that runs behind you, and a service worker knows what are you the most likely thing to click on. And so even before anything happens, the service worker is already prefetching all of the code in a very specific order. So it makes sure that like, oh, I'm noticing that people are clicking the buy button first. I'm going to make sure I download that code first before I download anything else. And I want to make an interesting point here is that if you have hydration kind of forces you to, it really doesn't matter in which way you order the code. Because with hydration, you need to execute all of the code before the page is interactive. You can't execute half of the code. That doesn't work, right? You either execute the whole thing, and I mean, for the components that are on the page, right? Components that are off page, those can be lazy loaded. But you either execute the whole thing or you execute nothing. There's no way to like say like, oh, I'm going to hydrate this component here first and then the parent components. And then that's not how this works, right? Like you have to start at the root, you have to go to the children. And so when you have hydration, figuring out in which order the code should be downloaded actually doesn't matter. Because it doesn't matter which order you download the code, it forces you to run it all completely before the page can become interactive. But because we can wake up individual components out of order and in any order, it actually starts making a difference in which order you download things. Okay, now the next thing I want to show you is that there's this +1 button, right? So if I click +1, you can see that the counter over here updates. And let me refresh this again. And so two things that have to happen, right? First of all, you have to download the code that does the incrementing, right? So this is the click listener that gets downloaded. Right? This code does incrementing. Then you're going to be re-rendering this UI over here. Well, actually, okay. So the framework showed up here. But in this case, we don't even need the UI over here because Qwik has something called signals. It's all the rage. And signals allow us to kind of know that like, oh, this particular button is tied to a specific location in a DOM. So if you increment this value, all the framework has to do is increment the value inside of the DOM, and that's it. There was no need to download the component or the parent component or the JSX to go with it or what have you, right? The only thing you kind of needed was just like to know the relationship between these two things. And so you might ask like, well, how do we do? By the way, Rich, how am I doing on time?
17 minutes in. Think of that when you go.
Okay. You're not gonna like stand with like a sign or anything. Okay. So let me show you how this kind of works. So first of all, how does the system know that there's a button over here? So is the font big enough? Can you see? Okay. So notice when you have a button over here, it says on click, and here is a URL, and this URL represents basically where the code lives with it. And this is what I mean, that the framework knows where the click listeners are, right? Without downloading any sort of code associated with the application, the framework can look at the HTML and be like, oh, there is a click button over here. I'm going to have to get a click listener, right? And not only that, the service worker can look at the HTML and be like, oh, there's a pretty good chance you might click on this thing. So I better go start fetching the code associated with this thing, right? So the fetching starts happening in the background, etc. You may or may not click on a button. If you don't click on a button, then we don't pay the price of parsing the JavaScript or loading it inside of the V8. But if you do click on a button, you can send a preload command so that the browser can pre-parse the JavaScript, but don't actually execute anything inside of it. So there's lots of different tricks you can do to kind of make it go fast. So let me show you this other button here. And this other button similarly has a click information. And on the end of it, there's this bracket 0. And this 0 talks about the state of the system. So if you think about, where's my state? Quick. There we go. If you think about what's happening here, like if I hit +1, this is incrementing. And if I'm incrementing this, the button can't just like wake up and be like, okay, increment. And the obvious question to ask is like, great, what's the current state? Like you need to know that currently it's 25, right? You can't just download code and be like, go increment. Like, yes, but like, what's the current value? Where do I start from, right? So you need to know that the current value is 25. And so this information here that I showed you in the button that has the bracket 0, this points into our internal basically state that got serialized. And this particular, I'm not going to go through it, it doesn't really matter. But the point is that it knows that this is associated with this counter. So it knows that the current value is 25. It should be in here somewhere. Where is it? Oh, here is the 25, right? So that's how it knows that the current value is 25. And then following some more code over here, this is how it knows to go and update the relevant parts of the DOM for it so that the component doesn't even have to download, right? So we only downloaded the click listener, not even the component inside of it. Now let me show you something else that I think is cool. So there is a button here, right? No JavaScript. Look, man, no JavaScript on the, never mind. You guys are a tough crowd. Okay, check this out. There is a clock on the bottom of this page. And this clock clearly requires JavaScript to run. So let me show you this again. No JavaScript. When I scroll to the bottom, JavaScript shows up and makes this component work, right? And it's a nice trick if you think about it, because why would you be bothering with downloading the code and getting the component up and ready if it's not even visible on a page, right? And the thing is, this particular behavior is just like out of the box. You don't have to do anything as a developer. So maybe we should go and say, hey, let's look at some of the code here. So let's look at this counter and counter this one. Let's make the font bigger. Can I make this smaller? Okay. So here's our button. So, okay. So first of all, notice here's our button that says, if you click on the greet, do console log. Notice that as a developer, I didn't have to do anything special to make lazy loading work. I just wrote the on-click handler like as I would normally would, and voila, it lazy loads. And in the system, not only does it lazy loads, the system can extract this particular information. Now this where it gets harder, for example, for the on-click situation, because this on-click closes over the count. Right? This count is a signal declared over here. Oh, by the way, I should probably make the font even bigger, right? How's that? Is that good size? So here's the count, and we can close over things. And so this is the hard part, which is it is easy to lazy load a function, right? We know how to do that. It's just dynamic import, piece of cake. I mean, it's not a piece of cake. You still have to do some stuff, put the function in a separate file, give it a name, put dynamic imports. There's a lot of boilerplate code you have to do, but it's not that hard, right? The hard part is that we in JavaScript have closures, not functions, right? This is a closure. It closes over the state of the count, and this count has to be restored. And so the trick that Qwik knows how to do is not necessarily, lazy loading code. It knows how to lazy load closures. So think about this for a second. This closure got instantiated in the server during SSR, right? When the SSR was running, this is the time when we created the closure, and this is the time when the count got closed over by the function, right? And then on the client, unless you actually click on this button, and it is only at the time when you click on a button does this closure get restored. And it's not just restoring the closure, it also restores the fact that this closure is closing over this signal. And a signal internally is closing over the fact that all it needs to do is update this DOM value over here, right? And so because of that, none of the other code actually had to be downloaded. Now, we also have our clock, and the only reason the clock is below the fold is because we put a div h class, which makes the screen go down, right? And so we can look into how the clock is implemented. And the clock is typical stuff, right? You have your styles, you have your state, and you have your JSX for rendering the clock. And then here is the bit that's kind of interesting, which is that, well, I need to run some code eagerly. How do I run some code eagerly? Well, if you have hydration, that's easy because you just run it when the component is instantiated. It's easy to run code eagerly, like set up a listener or something like that, right? But if you don't necessarily know when this particular component will be woken up or becomes visible, you need some kind of a hook to do it. And so use visible hook is basically a way of saying like, hey, run this when it becomes visible. And it's at that time where you set up a interval and go and start updating the clock every few seconds. And what's interesting is that you would think that because this is updating the JSX, that the JSX and the component would download, but no, the only thing that needs to be downloaded is this function right here. The fact that this function closes over the signal, which then in turn closes over the DOM elements, is all that is necessary for the system to run without ever downloading the clock. So for example, notice that this says console log render clock. You can see that on a server, it is indeed saying rendering the clock. But if I go to the console here, no clock is being rendered, even if it's fully interactive, right? That code never made it to the client. Okay, I think I'm going to be at time soon. So I want to show you one more demo, and then I will hand it over to Rich. Okay, let me show you something that I think is super cool. Don't stress. Okay, let's see. Think of questions. Let's see, where's my greet button? All right, here we go. So here's our, sorry, that's not our, oh, sorry, it was in here. Here's our console log read. Okay, oops. I'm just gonna make it in a new line so that it's easier to read. Okay, so we have our button reading, right? Here's our console log, right? So if I go and I click on the greet button, it says hello, right? Now I wanna show you, one of the things we talk about in Qwik is this idea that there is a unified execution model, which is like, you shouldn't really have to think about whether your code is running on a server or on a client. It just kind of does the right thing. We can go deeper into it, why it works, or security implications about it, etc. But I'm just going to glean over that for now. Now, what I'm going to do is I'm going to say const function equals, I'm sorry. I don't know how to do JavaScript because I've been doing way too much OCaml. Hold on. Function like this. Okay. So, and I'm just going to run it, right? So I really haven't done anything. Do you agree? Like I just moved it and still works. Okay. What I'm going to do now is I'm going to wrap this with a server dollar. Okay. Any ideas what's going to happen? I'm going to click on greet. Oh, look, it's no longer printing because it's printing on a server. I've just teleported the code from the client to the server. Now, in here, because now I'm on a server, I can actually go and put things like reading files, etc. I know Rich is thinking like, this sounds like a horrible idea. But there are, it's a deeper discussion of the security implications of it and how, actually, I don't think this is a problem at all, but it's a much deeper discussion. Anyways, I think this is kind of cool. I'm going to stop here because I could talk for hours and I don't want to take it away from other speakers, etc. But if people have questions, I'm happy to take a few minutes to answer them before we go on. Yes?
Once the framework installs and activates, if there's an update on the server side, any of the files, what kind of caching policy?
Yeah, so how does the caching work? Okay, so good question. We have like, works one way in version 1, works a little bit differently in version 2. The short answer is we use rollup to kind of build all of the artifacts. And we don't actually know which artifacts will make it to the client and which will not. because you kind of need to observe how the system runs. Anyways, once the system actually observes and runs it, then it can do all these optimizations that I showed you, right? And then the service worker actually knows in which things it can pre-cache. Now, the service worker gets a manifest of all the hashes, and the service worker can really easily then look inside of its cache and be like, oh, do I have this hash? Yes or no, and download. Now, other systems can do this trick too, but typically it's not so simple. So typically you have like a application, like you have an application that has lazy loading and people are like, oh, but look, I can change one file. Not really, because if you change that one file, it changes its hash, and there's a dynamic import in some other file. Now that file has to change its hash, which then causes the parent file that it loaded to do this, right? So there's this cascade effect that happens in a system. This doesn't happen in Qwik, and the reason for that is because fundamentally we don't have this cascading. It's not because, so like this click button was not loaded because there was some other file that hydrated and then told us about this particular thing, right? The thing loaded because in HTML, it just had a hash to go directly to it. So there is no, or that's not true all the time, but like for the most part, we don't have this problem that there's some parent file that also has my hash and has to be recached. So in case of a Qwik, it's really true that you can go and if I change just the behavior of this button, then unless the button is bundled with other things, then that button is the only thing that will change in the hashes of service worker. And so you will download just very little amount of code between the updates. So it's probably a much longer answer than you wanted. Back there, yes.
It sounds a bit like branch prediction. I think the idea is really cool. What are the inputs that are used for that prediction?
Oh, so how does this work? Okay. Sorry, the question is, how does this bundling system work? Okay, so let me show you this pixel. So a couple of things to notice. So this is the correlation matrix. The first thing to notice is the correlation matrix is mostly empty, right? It's mostly white, and there's this diagonal in the center because that's the identity that talks about like the file itself. So you can kind of ignore that. But I really want you to point out that it's mostly empty. So what we collect is information about like, hey, we noticed that function A ran, and then we noticed that function B ran. And so we have some limit of like, so how close together do these two functions have to be before we consider them related, right? And so this information is actually collected over many, many runs, as many users have different behaviors. But fundamentally, what we're looking for is this correlation of like, what is the probability that you will need this other code given existing code in here? And then you can have a slider. And the slider basically allows you to say, well, what's the cutoff point? If you take the slider to one extreme, then the system will just bundle everything into a single file, right? And if you take it to the other extreme, the system will just put every single function in a separate file. And the happy thing is somewhere in the middle, right? So you have this kind of a dial, and you kind of can get to decide like how strongly correlated do these two functions have to be before the system should consider them and put them in the same bundle. Now, what I like about this is that you didn't have to do anything as a developer. Like you didn't have to think about how to put things together or how the GitHub should load stuff, but it's not working. There we go, finally. If you kind of go through these functions over here, you'll notice that all of this have to do with our search bar on our homepage. This is actually our homepage. And so when people navigate and usually click on a search bar, all of these things automatically kind of get bundled together because the system's like, oh, I see people clicking on a search bar. And when the search bar is clicked, this UI comes on, and this UI has other components, and these components have click listeners, and all of these things kind of always happen together. And so as a result, the bundling kind of puts it together and zips it up into a single file and says, hey, this kind of happens in there. You said you have two questions. What's the second question?
Thanks. Yeah, great answer. The second one would be, is it feasible to at some point integrate these ideas into other frameworks, or do you think it will always be a very different thing? Because we all love having one more JavaScript framework.
Yeah, it's been X number of days since. Okay, never mind. That's a hard question. So I have a good buddy, Ryan Carniato. He lives not too far. We drink beer and eat burgers a lot together, and we talk about this particular thing a lot. And we're trying to kind of basically figure out like how could this be added to existing frameworks. And the sticking point is that existing frameworks have existing assumptions that are kind of not really compatible with it. For example, existing frameworks basically don't deal very well with lazy loading. No, not lazy loading, sorry. Asynchronous operations, right? If you look at the rendering pipeline in most frameworks, it's assumed that you say render, the whole thing is going to go through, and then synchronously you're going to update the DOM, right? It's difficult to be doing it in parts because you can't be just like rendering and then all of a sudden you decide like, oh, I'm missing some code. What should I do? Right? Then you have to do some kind of retries. Like it just gets tricky with these situations. That's one problem. The second problem is, again, most of these frameworks assume that they have all of the code available. And because of that, they kind of assume that like rendering starts at the root at least once. So this is an important thing. Like many frameworks are really smart about like how they do the rendering, but at least once on startup, they start at the root and render everything, right? And by that point, like at least once on startup means you had to download the code, which means the game's over, like the thing was already passed. So I would love to figure out, I don't want to say it's impossible because you never know, but it seems hard. And so I don't know.
Thanks.
Over here. What happens when you navigate to a new page? You mean like in terms of the lazy loading and stuff? Okay, so provided that it's a page that's been in production for like, I don't know, for more than one version, so you pushed more than once, right? That this quick insights already has all the data, etc. What's going to happen is you navigate to the page, you get pure HTML shown to you, so the application that you see is rendered immediately because it's just HTML. And one of the first things we do is we do two things. One, we load this super tiny piece of JavaScript code we call Qwik Loader. It's only about 1 kilobyte. It is so small that we actually inline it directly to the HTML so that we don't have another round trip to the server or anything like that. And all of this thing does is it sets up a global listener for anything that happens. And all it knows how to do is that if there's a global listener, the events bubble up. And at the root, it intercepts the event and then looks at the DOM and says like, can I find this on click somewhere to see if I have to download some code and do something? And if it doesn't find it, it doesn't do anything. If it finds it, then it goes and downloads it, right? So that's the Qwik Loader that happens. In parallel, depending which strategy you choose, you can either have a service worker or you can have the preload, module preloads inside of your code. And so in parallel, let's say you have a service worker. The service worker gets a manifest. Basically, it gets like kind of the overview of what the application looks like. And in this overview, it contains information about in which order it should download the code. And so immediately, without you having to do anything as a user, the service worker starts prefetching all of the code into the cache, right? So that by the time you as a user go and click on a button, the code is already downloaded. Now, you might ask a couple of interesting questions, which is like, hey, most frameworks download all the code. You download all the code in the service worker. What's the difference? Well, the first difference I want to point out is we actually don't download all the code. Because if you look at an application, you're going to realize that most components render exactly once. Most components are like layout components, or they're static, or they don't really do anything. They're really meant there for like structural reasons. They don't actually have any behavior in it. Right? And if you have a static component like that, that automatically gets thrown out by Qwik because you just don't need it. And so if you have a large website that there's a bunch of things in and there's a buy button in the middle, most systems kind of need to get all of the JavaScript there, even though like the buy button is the only thing you need, right? So Qwik, the first difference is that Qwik kind of like pulls away the stuff that's never downloaded to the client and never actually ships it to the client. So first of all, yes, all frameworks download code, but Qwik already has an advantage because it has to download so much less code, right? Because we're only downloading the behavior, not the whole thing. One. Two is the V8 doesn't have to parse all of the JavaScript. It only has to parse the JavaScript, obviously, the framework, but also the interaction that you happen to do. So if you click on a button, then we only have to parse the interaction of the button and maybe the shopping cart, but not anything else on a page. And hydration is particularly problematic because when it starts up, the V8 didn't have a chance to warm up. And so it's running in like the slow interpretive mode, right? Like it's not jittered yet. So if you look at a lot of performance metrics, a lot of these performance metrics are like, we ran this for like 30 seconds and it was nothing but running in this loop and the jitter had plenty of time to optimize the heck out of it and we're this fast. That's nice, but that doesn't mean it's going to transfer to like startup performance because when you have a startup performance, you're running the code for the very first time. And so no jitter is present. And the more code you have, just the slower the particular performance is. And there's a huge difference in performance between running code in JIT and running code in like the interpretive mode or whatever. I mean, you can debate what it's called these days. Sorry, I feel like there was more to it, to do a question that I'm not answering. Okay. Any other questions before we hand it off? One more.
The Qwik's ability to actually load the functions without like starting from the root tree or the component tree.
Mm-hmm.
So that's what makes it unique. So I want to know, how did you come with this approach, and basically what were the challenges that you faced while implementing it?
Yeah, good question. So how did the Qwik came about? Okay, so there's a little bit of a history. So, you know, everybody stands on the shoulders of giants, right? So Google has internally this framework called Wiz. And there's also another framework called Marco by eBay. I actually didn't know about Marco. I learned about it later. But Wiz is an internal framework at Google, and Wiz powers many things like your Google search, for example. And one thing you can say about Google search is that it's fast, right? Like, it's always kind of amusing to me that if I want to spell check a word, the fastest way to do it is to open up a tab in a browser and paste it in there, and I will get a result. And that's the fastest way for me to get to see if I know how to spell or not. The answer is no, I do not know how to spell. And so Google actually lives and dies by the fact that like it has to be fast, right? And so Google actually does something very, very similar to this, where they have something called JS Action. It's actually open source. You can look at it, and they render it. Now, the thing that Google, the Wiz is different in is that it is not a very good developer experience for a lot of complicated reasons. But like, if you look at it from the point of view of Google, all they care about is speed as far as for the user, right? That's the only thing that matters. Like, we have plenty of cache, we can throw at it plenty of developers, they can be super smart and figure all these complexities out. It's not a problem, right? So if you look at Wiz is just optimized for one thing and one thing only, and it is startup performance. Nothing else matters. And because of that, it's just kind of difficult to kind of understand and use, etc. And also, I think it's basically impossible for it to ever be open sourced. So I kind of looked at it and said, hey, this is this good idea of like, don't download all the code at once and only download the code if you have a behavior. How can I turn this into something that is actually has a user experience that people will use? And the magic comes down to this $ right here, right? Which can I call it Rune? We have a long-standing debate. It's copyrighted. Rich is really good at naming things. I mean, amazing. Anyways, so this is a marker, and this marker tells the compiler magic happens here. But it's not just for the compiler, it's also for the developer, because the developer also has to be aware that magic is happening here. And there's certain rules you have to follow whenever you see a $, right? So you have to, it's not just completely magical, like you just have to know certain things. We can go into discussions of what they are, that's not really that important. But what makes this possible is that every time you see a $, what you're telling the system is, I want you to make this thing lazy loadable. And the important thing to understand is that it's not like you can forget to put the $, because this is part of a API surface, and TypeScript says that the API has a $. So it's not like you can not put it there, right? The TypeScript going to scream at you, be like, I don't know what a component, where's the component? I don't know what a component is without the $. Like, you have to put it in there. And so the system basically, every time it sees this $, that is a message to the compiler to like, hey, do your magic. And specifically, the magic I want you to do is I want you to figure out how to take that function that follows the $, and extract it and put it in a separate file, right? So the idea is, you want to take your source code, and as a developer, you shouldn't have to think about any of that stuff. You're just like, building your web app, and you want to break it up to as many small little files as possible. The more files, the better. Right? Now, obviously, you don't want to ship it like that to the user, because that would be way too many small files. So then you have this other step where we combine things that are related. And it turns out combining files is easy. We have been doing that forever, and we're really good at it. Breaking files apart, that's the hard part, right? So the magical thing really of Qwik is really this ability to automatically, just through a tiny little syntax, lazy load, basically put things in a separate file and give each function a unique name that you saw earlier through the hash, etc., and then lazy load it, and then deal with the fact that this function can actually be a closure, and it can close over state, and this closure can be instantiated on a server, and then retrieved on the client, so you can do these kind of trickeries. So like, for example, we showed this trick with the server dollar. I could, for example, say, could say count.value here, and it would work exactly as you would expect, right? This function, this closure gets instantiated in the browser and then gets shipped to the server and then executed on the server. So that means the server gets to see what the value of count is. Okay, I think we're out of questions, right?
Yeah, so we will also have a small discussion round at the end where you can
sorry if I took too much.
explain or where you can ask more things.
Anyways, is Rich next, or are you?
Yes, we will have like 2-3 minutes to set everything up, and then we go on with the next talk. Feel free to grab some food, or if you have to use the toilet, it's in this direction, then onto the right. You will see it. You will figure it out. Yeah.
I already told. Which joke did I tell? Because I always have to finish with a joke. What was the joke I said?
Calling functions.
What? The parent, but like, what are the computing joke? I said, how do functions break up? Oh, that should be an engine joke. Okay. How do you measure functions? You measured functions in parameters.